right, well, thank you guys for joining us this morning for what I think is our most well-attended session. For those that I don't know or that we haven't met, I'm Andrew Clark. I'm Vice President of Government Affairs for the Home Builders Association of Virginia. I do all the work dealing with our state legislature, as long as our regulatory work with DEQ, along with DHCD and our building code. So we appreciate all your support. You know, we're here to serve you all, to represent the industry's interest. And so you're obviously here because you care about building codes, and we get heavily engaged in that, work closely with the department. And so we really need every one of you, especially as we get into the next code cycle, to be a resource for us and help guide us through that process. So I'm going to stop talking and introduce our speaker today, Jeff Brown, and I've got his printed bio here. So I'll read that. Jeff joined the Virginia Department of Housing and Community Development in 2017, bringing with him 20 years of experience in the construction industry, including 14 years in enforcement and administration of building and fire codes at the local level. So Jeff is the State Building Codes Office Director, and he oversees the code development process, so the process we use in Virginia to update the code every 3 years or so. Jeff holds 27, wow, I didn't know that, that's a lot, International Code Council enforcement certifications, including Master Code Professional Designation, which is the gold standard for demonstrating proficiency in the code profession. I'll say on a personal note, Jeff, having to deal with a lot of state regulatory agencies, Jeff is an invaluable, whole department and his team is an invaluable resource for the industry, is always there to kind of help guide us through, hey, what's coming up next? What can we do to help? You know, we have builders reach out and say, what does this mean? It's truly an honor to have him here and spend the next 6 hours going through the building code update with us. And so with that, Jeff, thanks again. Round of applause for Jeff, please.
Thank you, Andrew, and it's great to see you all here. Most people, when you say, hey, come on in the room, we're going to talk about building codes, they run the other way. So it's great to be with a crowd that's interested in knowing what's changing in the building code. And I don't know if any of that stuff that Andrew said was true. I do have some certifications, but really these gentlemen with me probably know a whole lot more than I do. I know how to read some slides, but if we have any questions, I've got Paul Mesplay, raise your hand, Paul, and Richard Potts right here. They work with me in the State Building Codes office. So if we have some questions that I may not be able to answer, they'll look it up. We're also, all three, we'll be here all day. We've got a table right outside, so if you have a question, don't get to it today or during this session, feel free to stop by and check in with us. We'd be glad to talk to you, elaborate on some of this stuff that it's going to be kind of fast moving. I've got a 4-hour version of this and a 2-hour version, and this is the 1-hour version. So I've tried to pick the highlights, the most important changes that I think you all would want to hear about. And what we're focusing on today is basically the VRC or the IRC changes for 1 and 2 family dwellings and townhouses coming up in the 2021 codes. But again, we'll be here all day, so feel free to stop by and check in with us. If you do have a question as I'm going along, you can stop me or raise your hand and we'll try to answer it as we go. But we'll also try to leave a few minutes at the end for questions, and then I'll hang around and they'll hang around with me for a little while after the session's over if we don't get to your question. All right, so with that, we're going to go ahead and jump on into our presentation. And so as you all probably know, the 2021 edition of the code was effective January 18th of this year. There is a 1-year grace period, just like we've had with past versions of the code, where during that 1-year period, and I think this is important to point out too, it's the permit applicant's choice to pick what edition of the code that they want to apply under. Sometimes there's some confusion around that it's the jurisdiction can kind of set that rule or decide that. That's not the case. It's the permit applicant. If you've got a design or something that you've been planning that you're wanting to build and stay under the old code, you can still do that up until January 18th of next year. You can still use the 2018 code. The first change that we wanted to mention, and this one is not really related to 1 and 2 family dwellings, but I think it's important enough, and there's probably some of you here that build stuff that's outside of the VRC, that's residential, multi-story, R2s or R3s, and this is a pretty significant change. We could probably talk for about a half hour on it, so I'm only going to hit on it for just a couple minutes. But again, we're out here at the table, and I've also, part of this change, it does take a lot to explain. So our agency actually recently put out a publication. It's about a 3-page explanation of what all the changes were between the 18 and 2021 code, and then some changes coming in the 2024 code. And we gave some recommendations to the building departments on how they might handle this and work with builders to navigate those changes. So in general, what happened was in the 2018 code, you were allowed to use a NFPA 13R sprinkler system and not have to go to the NFPA 13 system if you were less than 60 feet in building height, and that was measured up to the top of the building. And then in the 2021 code, what they did is they reduced that height to 30 feet, but they did move that measurement to the uppermost floor. So the highest floor above fire department access, if you're more than 30 feet there, then you can't use the 13R system. At face value, it didn't seem like that big of a change initially, but then I think as we looked at it, as some builders started looking at the change, and this came from the national level, this was approved in the IBC at the national level in the 2021 codes. What we realized was, a lot of times when we're using 9 or 10 foot ceilings and we've got ceilings that are a little bit thicker for our MEPs and things like that, maybe some floor trusses that might be a foot or even more in thickness, that some of these 2-over-2 townhouse type construction that we're used to seeing everywhere, wood construction, R2, 13R sprinkler system, some of those are not going to meet that 30 feet. That top floor is going to be more than 30 feet, which could, obviously really impact the building. It would have to be, lowered. The ceilings heights are going to have to be lower. It's going to have to put in a 13 sprinkler system. And so just some background on it. The change was really intended, I believe, to address podium construction. Some of you are probably familiar with that. We're seeing some of that probably more so up in Northern Virginia, some of the more urban areas where we're doing concrete parking decks with R2s on top. And so under the 2018, you could still do that and probably have a 5 or 6 story wood building with a 13R. So they were trying to clean that up and make sure that didn't happen, and inadvertently, this is what we ended up with in the 2021 code. So that was adopted in Virginia. We looked forward to the 2024 code, and they have done some updates to that. They've increased the height, they've changed where you measure to, and provided some relief in the 2024 codes that will help a lot of those 2-over-2 townhouse type buildings still use the 13R, still do the 10-foot ceilings. But there are some changes that podium buildings are not going to work. You're not going to have a 4-story podium building under the 2021 or 2024. So there's a lot to navigate there. So there is some relief in the 2024 code. So the memo that we put out kind of explains all of that, kind of lays out all the details and encourages the local building departments, hey, if you get a project under the 21 code, be aware that it's changing in the 24, so you can use that 24 code as basis for a code modification if somebody requests it, to consider it, and we would recommend that it would be appropriate to approve using the 2024 provisions now instead of waiting until we adopt that probably another year or a couple of years from now. So again, that one we could talk about for a long time, but that's the kind of highlights of it, and we've got the whole handout. We've got a bunch of copies out there. We've got it on our website. And we'd be glad to explain it in a little more depth if you would like that. All right, so now we're going to jump into the Virginia Residential Code changes. And we'll start off with a couple of definitions that have changed in Chapter 2. The first one being the definition of townhouse and townhouse unit. The townhouse is now the building that contains 3 or more attached townhouse units. And a townhouse unit is jump forward a little bit there, the single dwelling unit in that townhouse building. So before, those townhouse was used a little bit interchangeably, and it could get confusing sometime. Am I talking about a townhouse building or am I talking about a townhouse unit? Well, now we've got both of those definitions that we can use to clarify that. I'm not sure why this thing is skipping on me, but. All right, and that's really the only thing we had in definitions, and then that gets us to Chapter 3. The first change that we had here was related to the maximum story height. And basically, the maximum height for a wood wall is now 13 feet 7 inches. It's done this before, and I don't know why it does this sometimes, but let me turn this off and try it again. All right, so 13 feet 7 inches. Of course, there are certain exceptions and things. I've got another slide here that goes into a little more depth on that. So basically, you can go, your stud height needs to be less than 10 feet. If you are less than 10 feet, it's no engineered wall design required, whether it's load bearing or bearing. Let me turn this clicker off and see if I can just do it by hand. And then if you go between 10 and 12 feet, if it's a non-load bearing, obviously you don't need engineering for that. But if it is a bearing wall, you could need engineering if your snow load unless your snow load and tributary width are below the maximum threshold. So those aren't going to be very, very big. So this is probably going to be a small roof that's resting on this wall if you're going to be able to meet those parameters to not need engineering on a 12-foot wall. And then you can go over 12 now up to that maximum height, but you are always going to need engineering for that. And there's still limits to that as well for non-load bearing walls. The main limiting factor there is if you have a small shed roof or something sitting on that, you're not going to get much tributary width on that before you need an engineered design. All right, the next change we have is related to townhouses, and it's how you handle the extension of your separation wall between your units and where you terminate that. And what this clarifies is that the wall assembly itself can actually stop. It's really jumping now. It can stop at the interior side of that exterior wall, so it's like where your drywall would be on the inside, and then you can just put a double layer of fire blocking in that exterior wall to extend the separation there to the exterior part of the exterior wall. All right, our next change is related to mechanical ventilation, and it's basically says a whole house mechanical ventilation system or a mechanical ventilation system capable of producing 0.35 air changes an hour is required in habitable rooms. And I'm sorry, this thing keeps jumping around, not sure. Is it? Let me see. All right, I paused it, and maybe that will work for it. I'll try to clicker again. And really the change related to mechanical ventilation systems is just to provide some flexibility. So it doesn't have to be a whole house mechanical ventilation system like we've typically used in previous codes, where sometimes that is maybe a bath fan or something like that that's on a timer or what have you based on the bedrooms. There's some other types of mechanical ventilation systems out there now that can meet that need, but they need to be able to produce that 0.35 air changes per hour. The next change we have is related to emergency escape and rescue openings. And let me see. All right, so if you're under a deck, basically you still need to make sure that somebody can get out of that escape opening and make it out from underneath the deck. So there's some minimum egress requirements basically, and that's going to be 36 inches by 36 inches. And what this might look like is almost like a little dugout area under there. If you don't have quite 36 inches, it may need to be some grading done to make sure that you've got a path out from underneath that deck from that egress window, emergency escape and rescue opening. And this is just another kind of view of what that might look like. Again, you want to make sure you have 36 inches wide and tall. I did see somebody was telling me they had a situation where this came up and they were trying to meet this and had to kind of do some landscaping under there, almost like a swale coming out from under the deck to meet it. And then if you're going to have steps coming out of it in the window well area, there's a new requirement that gives you the minimum dimensions for those steps. And you've got 5-inch minimum treads, 18-inch max rise, and then 12-inch minimum width. This change is related to the slope at the bottom of a stair or landing on the exterior of a house. So basically it's allowing a little bit more slope there to get the water away from that stair. So it's allowing up to 2% slope. And give me just 1 second. I'm going to exit out of here and see if this thing has a timer because it will not stop jumping on me. All right, I think I got it.
Start telling some jokes.
All right, I think I found the right button, so we'll see what happens. Now the next change we have is related to smoke alarm locations. We've had them outside of the bedrooms. However, this requirement is specific to where you have different elevations in your ceilings, which we have now a lot of days, kind of like a tray ceiling or just a higher 2-story room or something like that. So if you have a smoke alarm outside of the bedroom, maybe in a hall or just that ceiling area outside of there, and then there's another ceiling that's more than 24 inches higher than that, now you need to add an additional smoke alarm in there because obviously your smoke's going to bank and collect in that area before it comes down and hits your smoke alarm in the hallway. So you're going to add an additional alarm there. And then there was a provision that now lets you put a smoke alarm a little bit closer to a cooking source, but it has to be listed for that reduced clearance from cooking sources. I didn't even know they made these. I'm gonna have to get some for my house because I know ours go off every time we cook for some reason, so they're really, really sensitive, but now they do have some that don't trip as easy with these nuisance alarms. This one is related to roof photovoltaic or solar panels or systems, and basically what it's saying is if you're using a building integrated, which is called a BIPV system, these are going to be your shingle type solar systems where they're not just individual panels that are set up on the roof. Your whole roof is basically your PV system. They don't require the access pathways and setbacks that you do for firefighting purposes on the roof. The firefighters will just access it by walking on top of that. Whereas the other solar panels, you do have to provide minimum clearances around it and at the ridge for firefighting operations. And related to that, there is a state amendment in Virginia related to those minimum clearances, setbacks, and access ways on the roof. And it really just cleans it up, makes it a lot simpler. This was a compromise and worked through with the fire service on how they really fight fires, and they agreed that some of the clearances weren't as necessary. So I think our version in Virginia is a little bit more lenient as far as you could get a little bit more solar panel on the roof and still meet the requirements compared to the model code. And it's a lot easier to navigate as well. It's really just a couple of easy measurements to take. Habitable attics, we've had a lot of Virginia amendments related to habitable attics over the years, and that keeps changing in the IRC, so we're trying to keep up with the IRC and make sure that the changes that we have in Virginia are maintained. So really there's not a change in the allowance for habitable attics or where you can have a habitable attic. But the change here is just to line up with the moving around at the IRC level. There was some descriptions or almost requirements in the definition of habitable attic, and so that definition's been cleaned up, and the actual requirements for the habitable attic have been moved to the section 326 that has the rest of the requirements for habitable attics. All right, that gets us into Chapter 4 on foundations. The first one is a cleanup of this table on footing widths and thicknesses. And this is really just done based on, common practice and things that we're seeing more often related to footing sizes. I'll flip here so you can kind of see what we're working with. This is what the table or a part of the table kind of looks like now. There's a roof load and a snow load that you can go to see what size footing that you need. And that gets us to Chapter 5, where our first change is related to the vapor retarder under a concrete slab. Now, previously you needed 6 mil. Now, under the 21, you will need 10 mil. I've had one builder told me that he had talked to a building official about this, and they basically said they would allow multiple layers as long as the total equaled 10 mil or more. But just know that's a little bit of a change there, a little bit thicker vapor retarder. And similar to the other footing size table, there's been a cleanup in the deck footing table. And this now more so recognizes that not all the footings that we do, especially for decks, are square. Some of them are more round. You don't need quite as much mass there that we've probably had required in previous editions of the code. So as you can see there, some of those footing sizes, if you're doing a square footing, go all the way down to 7 or 10 inches. So instead of having to use like a 12 by 12 solid concrete block or something and dig a pretty big hole, you can get away on a smaller span joist with a pretty small footing now. Some additional changes related to decks. The deck post height table has been updated, and really what it did was it put in things regarding the species of lumber, and the tributary area, or the amount of floor area basically that's bearing on this post. So once you get those pieces of information, you can plug it in here, and that's going to tell you the maximum height that you can have for your deck post that's underneath supporting it. That gets us to Chapter 6. First change we have is related to cripple walls, and this is really a clarification that when there's requirements in 6029 related to cripple walls, this is only dealing with the exterior cripple walls that are going to be part of kind of your wall bracing, really, and not those interior cripple walls that you might put in the crawl space. Some of the requirements do require you to sheathe those walls and things like that, so obviously you don't want to do that in the crawl space and block your ventilation to access and things like that. So this is just clarifying that that's not the intent. I guess it's Chapter 7. First change we have is related to vapor retarders, and this is really just kind of a cleanup. However, they have gotten rid of a couple of types of vapor retarders, but they have these in 3 classes, and the next slide probably shows it a little better. Maybe not. And so basically, you'll classify which one you want, and then there is a table. We don't have a copy of it in here, but based on the climate zone and what have you, it's going to tell you which class vapor retarder that you need. Again, it's not really a change; it's just a cleanup, and it's now in a nice clean table. There were some changes related to your brick ties and the airspace that you have to have behind your brick, and this is mostly related to where we're seeing a lot of continuous insulation now. So obviously you need some more room in there to get that. So this table now will tell you what your maximum your minimum airspace and maximum airspace should be, but also allows that extra room for your continuous insulation, and then addresses how many wall ties you need based on what type of construction and wall tie type that you're using. Soffits, there's been quite a few changes related to soffits, and we'll just kind of hit some of the highlights. But basically, this is just putting some more prescriptive requirements and minimum requirements, mainly related to the attachment of soffits. Over the years, as they've had some pretty good hurricanes, mainly down in Florida, and they've done studies on houses that got damaged a lot. A lot of it tied back to the soffits failing, and once the soffits fail and that wind gets up under the roof, it's able to get the roof off, and then once the roof is gone, you get the whole house is damaged, basically. So they've found that if you can keep that soffit in, your roof has a much better chance of staying on. So the attachment becomes critical there, and so this kind of shows the various subsections through there, and you can see it's broken down in different type of material. Here's a couple of diagrams that you'll see, and again, this is kind of showing where you need to put your blocking and where you need to put your minimum attachments. And then there's also always if you're using a vinyl or another proprietary type material, they're going to have manufacturer specifications likely as well. So you'd want to also make sure you comply with those. Whichever one is more restrictive would apply in that case. All right, that gets us into roofs. So there were some changes to this heel joint connection table. And basically, it's really related to 24 and 36 feet spans. And if you have a 19.2 inch rafter spacing, which I don't see a whole lot, and that's a pretty big span. But if you do have this condition, there's some updated joint connection requirements there for those specific spans. And then this one is pretty important too. There's a note that says 10D common nails shall be permitted to be substituted for 16D where the required number of nails is taken at 1.2 times the required number of 16D. So basically, if you use the smaller 10D common nail, you're just going to multiply in that table. If you need 10 required, you would have to have 12. So it's just going to increase it a little bit. All right, and that gets us into energy, where we've got a few changes. The first major change that we have is that historically, Virginia's been in climate zone 4 everywhere in the state. It didn't matter where you were, everybody was in a 4. Now they've redone the maps a little bit, and we actually have 3 different climate zones in Virginia. We've got some 3A, which is a warm humid, and then we've got some 5A, which is a cool humid. And I'll take a little zoomed in view here to give you a little better idea. So you see the 3A warm humid kind of runs along the southeast part of the state, and those localities that are kind of right along the border with North Carolina and over to the coast. And then we've got our cool humid is up more towards the ones that border West Virginia. And we've got a list here of which counties fall into which category. So those are the new ones that are in the 3A and the 5A, and the rest of them still remain in the 4. That becomes important when you look at your insulation requirements and things like that in those tables. There's different values for those different areas. Another energy change is your compliance options. So the compliance path options have been clarified, and the prescriptive and mandatory labels that were all throughout the chapters have been removed. Again, just a really more of a cleanup in how you use the chapter. But they did add some what we call additional energy efficiency requirements. And so if you use a prescriptive compliance path, you would go to this section and pick what we call a package from this section to add to your minimum prescriptive requirements. If you do the total building performance compliance path, you either include one package from 1108 or the design has to have an annual energy cost less than or equal to 95% of a reference design. So you've got two options there. You either put the additional energy option or package in there, or you can just do like a building modeling and show that you're less than or equal to 95% energy use. And then projects complying with the ERI path do not require any of the additional option package that are in 1108, but they have to have a score of at least 5% less than that in the ERI table in that section 1106.4. So again, whichever path you choose, you may have to do a optional or additional energy package, and here's what those energy efficiency package options are. The first one is an enhanced envelope performance option. The second one is more efficient HVAC equipment performance. The third is reduced energy and service water heating. Then we've got a more efficient duct thermal distribution system or improved air sealing and efficient ventilation system option. So again, you would pick one of those depending on which compliance path you picked, unless you meet one of those other exceptions and are showing that you're more efficient than a standard building design. All right. There was a change related to the energy certificates that we're now putting in buildings. The certificate isn't new this time around, but they're adding some more minimum information that needs to be on it. One is the size of the heating, cooling, and service water heating equipment. There's also some things for your fenestration U factors. If you have PV system, there's some information that you need to add there. And then if you use the ERI path, the ERI score has to be included on that. And then you also have to include the addition of the code that the building was designed and constructed to. Under the building thermal envelope, there was a couple of changes. One kind of general change or concept that they're going with is previously the R factor or R value was more commonly referred to, or at least in my experience when I was doing more inspections, everybody kind of paid more attention to R value. Now a lot of things are leaning more towards U factor, which is more of your assembly rather than looking at just individual materials or components. And since that's become more prevalent, they've kind of reversed the order in the codes, and like the first table that you'll come to, instead of being your R value, is going to be your U factor, and the R value table is more of like a additional way you can do it, but they're leaning, everything's kind of leaning more towards focusing on U factor, and R value is kind of becoming the alternate way of getting there. So basically, again, when you get into the tables, the U factors have been lowered a little bit, and the R values have been increasing a little bit, generally at the national level. And we have had some changes in Virginia too that we'll go over on the next slide. But again, those tables have reversed. And the first one we'll look at here is the U factor table. As you can see in Virginia, we did have some little bit of a change there in the climate zone, and what we're showing here is just the 3 climate zones now that are in Virginia, 3, 4, and 5. You can see there was a slight increase there in 4 and 3. However, in 5, starting at the left side, those have stayed the same going into the 2021 code, and we'll see that again in the R value table that if you're in one of those jurisdictions that's down at the bottom, some of the insulation requirements have not increased this time around. And here's the R value table that's showing the same thing again, but just in R value. And again, if we look at the ceiling R value, and if you look at climate zone 3, the ceiling R value has gone from 38 to 49, and the climate zone 4, it's gone from 49 to 60, and then in 5, it's gone from 49 to 60. One thing I will point out here that's important is that although the 2021 codes have increased in R value for the ceiling, when we go to the 2024 codes at the national level, there was some compromises reached at the national level in the IRC where the R values rolled back some for some of these. I don't have all the details with me right now, but I think the ceiling R values basically went back to what they were in the 2018 codes. So when we're getting questions about it now, we're telling folks, hey, it makes sense to me that you would look at the next edition of the code and see that it's reducing, and it'd be a good reason to accept that now, just like we do with a lot of other code changes when we know they're coming down the line. Maybe you need to do a code modification or request that. I know one jurisdiction I talked to was looking into it, and I think he just put out a memo basically saying that he'll allow the use of the 2024 R values now under the 2021 code. So keep that in mind if you run into that. There could be opportunity there to work with the building official and just say, hey, look, we'd like to reduce the R value back to the 18 because we know that's coming. To me, it just doesn't make sense if I'm going to build a house this week and make somebody put R60 in the ceiling, and then in a couple of years start putting R49 back in there. To me, it just makes sense to keep it at the 49 as we go forward. And there were a couple of other changes. The wall, the big one here is the wall insulation did not change. So we've got the R value 15 or 13 plus 1. Same as the 2018 edition of the code. So again, this is what we've been doing so far. No increase to 2x6 studs needed or adding continuous if you haven't been doing that already. We're still the same there. There were some changes in these other ones. I think some of that is really just adjustments and not so much increases, just different ways of measuring it. But your basement wall is, depending on which zone you're in, is either a 5 continuous, 10 continuous, or 15 continuous. And then your slab is 10 continuous, regardless of which one that you're in. So really the main change here was really just the ceiling R value. Now the fenestration did go up, and that stayed in Virginia, but the ceiling R value went up. But again, I'd encourage you, if that's a concern, that you could ask the building official if they'll accept the 2024 R values on a project. Related to ceiling insulation requirements, although the values are moving around a little bit, regardless of what the value is, the kind of exceptions for your slope ceilings and where you have ceilings without attics and those sort of things, there's a couple exceptions there that would let you reduce the R value in your ceilings. Those still remain. Of course, if you're looking at the new increased R value, your reduction might increase to one level below that, but in general, those exceptions work the same as they did before and are still in place. Floor insulation, this is really just kind of clarifying that there's different ways you can install your floor insulation. It doesn't necessarily have to be up against the bottom of the floor sheathing. That's the way most people have done it for a long time, but if there's a benefit to putting it at the bottom, this gives you some options for doing that. Obviously, you've got to address kind of the gap at the sides if you do that, and maybe add a little bit of insulation there or some sealing to seal up any airflow. And then unconditioned basements, this is really just to make it clear on if you want to call something an unconditioned basement, what needs to be done to consider it unconditioned. And some of the things that are required are like putting in an insulated and weather stripped door. Obviously, the stairwell coming down to that door is going to need to be insulated and separated from that building thermal envelope. And then any kind of ducts and pipes and things like that, if you don't want them to be in the unconditioned space, are going to need to be within or on the other side of that insulation. Or if they're in the basement, you would need to treat that as an unconditioned space and insulate those ducts and pipes and what have you. There's a requirement for air sealing of electrical boxes now in your exterior walls, obviously. And this is similar to years ago when we had all the can lights, and then we started having to require the air sealing around those. Same concept, this is just for your electrical boxes. So some boxes are probably going to come with this on it already, and they're going to have marking on them for a NEMA OS4, or it might say OS4 on them or something, and it's probably just going to have a little strip on the outside of it that's going to provide that seal for you. This change basically is saying that the heat pump needs to be used as a primary space heat source. And really the general idea is that you can't use electric baseboard heat or solely electric heat for your heat source. So not that you can't have an electric heat pump, but it can't be operating solely on the electric heat strips in it. The primary heat coming from it needs to be your heat pump. And then so to clarify that, it also gives you some parameters for when you do have your emergency strips or whatever in your heat pump. It's going to have certain settings that have to be in place so that it's not running on electric heat all the time. So basically, it'll have a setting so that it doesn't come on unless it's below 40 degrees outside. But there'll be some overrides for defrost and for emergency heating modes and things like that. Basically, same thing I think that most heat pump systems are already set up to do. This is just really putting it in here in the code to make sure that they're being programmed and installed properly. And there are some exceptions, I think. If there's no way that you can put in the ducted heat pump or ductless heat pump, you could possibly use an exception to put in a baseboard heat or solely electric strip heat. Duct testing. This has just added, we've already been doing duct testing for a couple cycles now, but this put in some specifications for the testing standards and ANSI and ASTM, the methods that you need to use for doing that testing. This isn't changing who can do the test or anything like that. It's really just kind of an update to those testing standards. And one kind of important change here is that ducts that are not, basically anything that is inside the building envelope also has to be tested. Used to, there was an exception that basically said if the ducts part of the duct was fully inside the building envelope, you didn't have to test that portion. Now the requirement is that all the ducts need to be tested, and I think the idea is obviously, sure, if it's inside the building envelope and you get some leakage, it's going into the building, but it could impact your design and your efficiency and things like that if it's not going where it's supposed to be going. And you could end up, if you have a big leak somewhere inside of a wall or something like that, and you might have a room that's not getting heated or cooled or air circulated like it's supposed to be. And that's the slide there that kind of explains that, your exception number 3 there. This change is basically, we had a conflict between the energy code and the mechanical code, where the energy code said you couldn't use a building cavity as a duct or return or a plenum, and the mechanical code had provisions for how you would construct or use a duct in a plenum. So the mechanical code really did supersede the energy code. However, it wasn't really clear which one would apply in some cases. So the requirement in the energy code that says you couldn't do this has been removed, and we've maintained the requirement in the mechanical code that tells you how to construct it if you want to go that path or use that type of duct in a plenum or a building cavity. This is something new, and honestly, I have to tell you, I'm not sure how different jurisdictions might handle this one. But basically, it says mechanical ventilation systems now require testing. So, like we talked about before, there has to be some kind of ventilation system, whether it's a whole house mechanical ventilation system or one of those other types of systems that are now allowed, providing a minimum air change per hour. And so those now need to be tested to verify that they're providing that minimum airflow as they were designed. But that's all it really tells you. So there's really no form, it's no standard on how this has to be done. So as this comes up, I would probably, if you're doing these things, maybe check with the locality first and say, hey, what kind of testing are you going to accept? Will you accept this? Can I just sign something saying it's been tested? Here's the air changes per hour. If you have somebody there that's already doing your duct blaster testing or your building envelope testing, maybe they can do these and add this as part of their test report, and I would imagine that should be acceptable. But there's nothing that says it has to be in a certain method or done by a certain individual or anything like that. So I would just plan on adding those additional whole house ventilation or whatever you're using for your fresh air into your testing now. All right, so this is still in the energy, but it's getting into some of the electrical requirements. We've kind of phased in more and more high efficacy lighting as we've gone along. And now we're at the point where it's 100%. So all of the permanent lighting fixtures have to be high efficacy. And then there's now provisions requiring lighting controls for interior and exterior lighting. We'll talk about that a little bit more. So for the interior, any permanently installed lighting fixture shall be controlled with a dimmer, occupant sensor, or another control that is installed or built into the fixture. And there are some exceptions for bedrooms, hallways, exterior lighting, and any kind of lighting that's required for safety. So in general, your main living parts of your house will need some kind of switch to increase the efficiency or to ensure that it's just not always on or always off based on the primary switch. I really like the occupancy sensors. I've used them in my house, and they work really well, especially if you have kids that don't ever turn a light switch off. I've gone through and put those in a lot of rooms in my house, so I don't have to go behind them and turn the lights off all the time, and they seem to work really well. They're really nice in the garage, too. I've got them in my garage, so when you walk in there, the lights come on. You walk out, lights go off. Actually, they're pretty nice. It is an increased cost, however, but again, it's not everywhere, and when it says other controls, I'm not sure, I'm not an electrician. I'm sure there's a lot of different things out there you could use. There might be some that have like some kind of light sensor so that if there's enough light coming in from the windows and stuff, the lights will go off so that you're not lighting up a room that's already meeting that minimum light level that you would want. Again, occupancy sensors, timers, whatever kind of control you would come up with here should be good. And then similarly for the exterior lighting, this says that lighting shall be controlled by a manual on-off switch that permits automatic shut-off actions. And there is an exception if it's multiple dwelling units, so you don't want to be cutting somebody else's lights off. But the lighting shall automatically shut off when daylight's present, so it needs to be dusk to dawn basically. And then you need to have controls that override automatic shut-off are not allowed unless the override automatically returns to normal operation within 24 hours. So you don't want it to be you override it and then it's permanently on and you've kind of done away with the automatic shut-off. All right, that gets us through the energy into the mechanical, electrical, plumbing. And there weren't a ton of these, so some of them, like the gas and mechanical, we may only have one or so for each one that were, pretty significant. This first one is related to gas, and it's some new definitions for your assembly, shut-off. It's basically trying to delineate when it's talking about a shut-off and a master shut-off, system shut-off, what point in that system is it talking about, because you've got a public utility involved in there as well. So these definitions kind of clean that up, and there's some diagrams to go along with that to show you exactly what that point of delivery and those sort of things are. I think when I came last time, I was telling you all that they had now allowed commercial appliances back in residential. Well, now we're flipping the other way again, and now commercial cooking appliances are prohibited if you're building under the VRC or IRC. However, I'm not sure that's going to be as big of an impact as it first sounds, because I think what has happened is some of the manufacturers have caught on to that people like these commercial appliances, so they're dual listing them. So if somebody really wants a commercial type appliance, they can now get one that's listed for residential as well, that's suitable for a house. And I think the main difference from what I understand in a commercial appliance are going to be things like our residential ones have more insulation and things in them to protect the user, whereas some of the commercial ones, they get rid of some of that stuff and it's really just for a commercial operation, and they're not as concerned with people that, they've got professional cooks and they're using it. So, and then also you have things like your anti-tip devices that we have on residential ranges that don't typically come on commercial ones. So again, they can still use those types of appliances. They just need to be listed for residential. 10 minutes, okay. All right, so I'm gonna zip through these last couple in case we have some questions, because we don't have a lot of time left. So on the DWV system testing, we've gone up to 10 feet ahead of water, which is a little bit of a change. They have added an air vacuum test as an allowed method of testing your DWV now, which could come in handy if somebody's got the equipment to do this, and it's especially when it's cold outside and freezing. I know nobody likes leaving the water in those pipes when it might freeze outside. So that's another option that you have. Hot water piping to fixtures. This is from the commercial code. We've been doing this for a long time. Now it's coming to the residential, that you've got a maximum limit that you can run, because basically after you run that hot water so far through that pipe, it's going to not be so hot by the time it gets there. So now you're limited to 100 feet of pipe. However, they do make circulation systems, so sometimes those can be put in at a certain point to circulate, and then you're really measuring from that point of circulation, because you've got hot water up to this point circulating, and so now you have 100 feet from there instead of 100 feet from here following all the piping around. In Virginia, we made a specific amendment to now allow solvent or your one-step primer and glue for CPVC to be green. So now you have some that are yellow, red, or green, just as long as it's listed and meets the requirements. Any of those colors work. This one is kind of significant, or could be. It's a requirement for a emergency disconnect on the outside of a house. So some houses already have this, and in general, most localities have allowed like 6 feet of service cable to run from your meter to your inside before you have to put in some kind of disconnect. Now there is not that allowance. There has to be some kind of disconnect on the outside. It doesn't have to be service equipment, so it doesn't mean that you have to switch to your 4-wire and run 4-wire from there. It can just be a disconnect that's used for emergency purposes only between that and your service panel inside. And this is really just for emergency access, so when the firefighters come, they don't have to pull the meter. They can actually just use this disconnect. I have heard some concerns with people just worried that somebody might come up and flip the switch and turn your power off. I mean, that is a legitimate concern, and I'm not sure how that would be addressed. But if that becomes an issue, hopefully we can come up with a way to meet this need that they have, but also make sure people don't have to worry about that either. So we'll see how that one kind of works out. There's another option in the code that allows a disconnect on the meter, but it's kind of built in as one unit. And from what I've heard, none of the power companies in Virginia are willing to go there right now. So maybe if they get enough pressure, maybe they'll be willing to start supplying those, and that way there doesn't need to be another disconnect or something installed in the line on the outside. But for now, I don't think that's an option. Typically, they supply those meters, and they're just not supplying those right now. There's a new requirement for a surge protected device. This is just something that attaches to the panel. There's ones that go on in different places, whether it's on the load side or the line side. But it basically is going to be like a whole house surge protector. Some of these might be actually built into the panel. Some of them might be an extra device that you install. Bathroom branch circuits. We've got, this is just a clarification again that if you have other outlets that aren't required, they don't have to be on that dedicated bathroom branch circuit. They can be tied into other circuits in the house. Just the required ones need to be on that dedicated 20 amp. There is a requirement here that basically says in a zone measured 3 feet horizontally and 8 feet vertically from a bathtub rim or a threshold, you cannot have electrical outlets and fixtures. This is a good diagram, and that yellow space here kind of shows you where that area is. Here's an example where you might run into an issue where you don't quite have 3 feet and 8 feet, but there is an exception for that. In that case, you would just put it over here on this far wall as far as you can get it away from that space, if that's all you had to work with. Similar to the kitchens, this one is just clarifying that if you have extra outlets in the garage, maybe for your garage door opener or something like that, and they're not the required outlets, then those can be on a different circuit and don't need to be on your dedicated circuit. Kitchen countertops, a little bit different way of measuring the number of receptacles for islands and peninsulas. and it's based on the square footage. So smaller one, you might still only need one, but if we get up over, I think it's 9 square feet on an island, then you might need to go with 2 outlets. This is a somewhat interesting one. It is requiring GFCI protection on 250 volt receptacles, but that's if they are in a damp location or in an area that requires GFCI protection. Used to it was only on the 120 volt. Now it's on the 250. It's saying a dryer here, but in my opinion, I'm not sure that a dryer is in a damp location, so I'm not sure that I would apply this to a dryer. But if you did have say a 250 volt outlet for a generator or a something in your garage for like an air compressor or something like that, and it was in a damp location, then yes, that could apply. Or if you had a sprayer or something in this laundry room for washing your dog or something like that, and it was within a couple feet of this, then I would say, yeah, you would probably need to put ground fault on that 250 volt or 250 volt outlet. This requirement is basically just requiring ground fault in all basements, regardless of whether they're finished or unfinished. Previously, it was just in the unfinished basements. Now it's in all of them. And of course, this is going to be, in addition to the other requirements that you might have for damp locations and what have you. And this one is similar again to the commercial code and what we were just talking about before for the dryer outlet. If you have an outlet that's in a damp or wet location, it needs to be ground fault protected. Again, and some of the details that I've seen show like a mud room or something. I don't think a mud room is a damp location. I would probably argue that one. However, again, if you had a bath for washing your dogs or something in there, which some people do, and you're spraying water and you got an outlet next to it, I'd say now you're in a damp location. But just because people come in from the rain, I don't think that makes it a damp location. To me, you need some kind of water source in that area. You might have an area like this outside of your bathroom, but I can't think of very many examples other than that. All right, and then we in Virginia got rid of a requirement for GFCI protection to outdoor outlets, and this is mainly related to issues we were having with nuisance trips on HVAC equipment, and there was this was recognized at the national level, but it didn't quite get taken out of the 21 codes. They didn't catch it in time, so we've taken care of that in Virginia, so you don't have to worry about that. And that, I believe, was the last slide for the technical changes. How much am I back, like 3 minutes, 2 minutes? All right, so I do have a couple other slides. We'll just, I think you all, I've given them the presentation, so these are really just some links and stuff that might be of interest that should be available after the summit. But this is basically a website where you can go, you can register, and you can see all of our training for all of our code changes online. Again, this is a reduced 1-hour version. There's a 4-hour version of this that has a lot more changes. And then we have things like commercial codes, fire codes, things like that as well if you're interested in signing up. And also want to make sure you are aware of this link is where you can get access to all of the Virginia code books for free. It's a very, very good resource, so you don't need to carry code books around with you anymore. If you can get used to it, you can actually access this on a computer. Sometimes it works from a phone, sometimes it's a little finicky getting through the table of contents and stuff and finding what you need on a phone, but definitely from a laptop or something like that or computer, you can get to it. And if you download the app, you can use all the digital books very easily from ICC. And other than that, I was going to give a plug for code development. Andrew kind of hit on that earlier. We appreciate all you all that participate in it. Would love to see more of you participate in it. Like I said, the more folks we have at the table, the better our codes are. The more input we have, the more perspectives we have, the better we can do at getting codes in Virginia that are top notch. And with that, I will wrap it up.